Bryan's project is the real-time planet tracking module, which calculates the position of the stars and points a laser at the stars. So Bryan's project was incredibly perplexing, and I honestly didn't really know what he was doing half the time, but I'm hoping he's only finding out about that now. So, yeah, but despite all of that, he really pulled through. He just was constantly putting his head down and working on his project as hard as he could, and he managed to come up with some really unique solutions to the problems that he faced. And all I can hope is that he remembers to hire me in the future. So here's Bryan.
Good afternoon, everyone. My name is Bryan. I'm going to be a senior next year at Mountain View High School, and this is my project, the Real-Time Planet Tracking System. I have a passion in astronomy, space, and aerospace engineering, which is what I want to study in the future. And although this isn't a rocket or a plane, I thought it would be cool to expand my interests, and that's why I chose this project. So before I get into anything, I'm going to demo the project. Right now, thank you. Right now, the laser is pointing at Mercury, and as you can see, to me, that is just right there. And if you don't believe me, you can go into Star Tracker, and you can go on your phone and take a look at it for yourself. But the cool thing about my project is that I can actually choose between different planets. So right now I'm on Mercury. If I press this button, that's actually inside my box, I can go to the next planet in the solar system, which is Venus. Venus is pretty close to Mercury. It's just about there. Third planet is Earth, and you'd expect it to kind of just be beneath us. And going off of that, the fourth planet, Mars. And that is right about there. And with my project, I'm able to track all 8 planets plus Pluto. And maybe in the future I can add different planets or even galaxies, but that's for some time in the future. So moving on, I'm going to go through the components. And even though this doesn't look like a lot, there's a lot of little parts that go into it, starting with the calculations. And the calculations are about the orbit of the planet, how far away it is from us, things like how circular the orbit is, and all those little things go into determining where the planet actually is. Along with that, I have a GPS here, and that is used to determine the position and in longitude and latitude, and the time. And the position is important because depending on where you actually live on Earth, you may have a different perspective. For example, if you live in North America, compared to someone in South America, you'll be seeing different things because the perspective above on the upper half of Earth and the lower half of Earth. Moving on from there, using those two, I can find what's called azimuth and altitude, and that's basically the angle between the horizon and from north, 0 degrees. And with azimuth and altitude, I tell the servos, which are the little motors here attached to the gears, where to look, and those aligning with the laser basically point at the planet. Talking about the servos, one of the biggest challenges I had was that the servos can only move 180 degrees. That means that this laser can only point at 1/2 of the night sky. And unfortunately, the planets are not only in 1/2 of the night sky. So to combat that, I had a gear system. This is a 1:2 gear ratio, meaning that if this bigger gear here moves 180 degrees, which is the max the servo can go, the smaller gear here can move 360 degrees, allowing me to 360 degrees of freedom and allowing the laser to look anywhere in the night sky. The second challenge I had, or the second big challenge I had, was CAD, which is 3D modeling. And with that, I made this 3D print here. The problem was that I had never CAD'd before, and this was completely new to me. So when I was making the sketches and making the design for my 3D model, I was all over the place, making a bunch of messy edits, and when I actually tried to use it, it was really hard to use, really confusing for me, and in the end, I had to redo the entire thing. In the end, I'm able to CAD now pretty efficiently, and I believe this will help me a lot in the future. With BlueStamp, I think that I was able to learn a lot more about space, about the planets, and how to track them, and I was able to learn how to CAD. But more importantly, I think I was able to learn how to overcome my challenges. At BlueStamp, one of the biggest things is that you're not allowed to ask your instructors for help until you've tried at least 3 times. Which may be to challenge you, or maybe it's because just Ricky doesn't know how the answer to the question. Anyways, because of that, I was able to learn from my mistakes and be able to overcome these challenges, to adapt and overcome them. Additionally, in the future, if I had more time, I would add one more component, and that would be a gyroscope. As you can tell, this thing is, if you couldn't tell, this thing is only adjusted to be north. Right now, that way is north, and the box is fixed. If I were to move the box, the gears would not move. With a gyroscope, it would act as a compass, and the compass would attach to the servo and the lasers, so that if I were to move the box, the gears would automatically adjust, so that I wouldn't have to manually place the box in the north part. And that is all. Thank you for your time. Are there any questions?
How long did it take to gather?
I'd say, I think it took me about a week.
So would you say the math, the coding part of it was harder, or would you say the CADing was harder?
I'd say they're both equally as difficult, just difficult in different ways. And I was probably equally as frustrated. But the good thing is that if I were to CAD now, when I actually ended up redoing my CAD, it took me about 1 day, maybe even like 3 hours compared to the entire week I spent making a messy CAD. So that's one thing.
How do you track the planets and positional information about the planet?
Yeah, so, sorry, go ahead.
Yeah, that was
So this information is actually all built off of each other. So you start with information from 2013, but since gravity doesn't exactly fluctuate too much over time, it's pretty constant, and using information from 10 years ago, I'm able to still calculate from where it is right now, since everything is constant. Does that answer your question?
So similarly, you could track any object in the sky then by giving it the, I forget the word you use, the parameters of where it is.
Yeah,
Not just planets.
Yeah, any information about its orbit, and it should be able to track it.
Right.
Any other questions? All right, thank you.